Good everyone, my name is Graphics. Today we want to solve another exercise on inclined plane, and the question goes like this. A block is placed on a plane inclined at 25 degrees to the horizontal. The coefficient of friction between the block and the plane is 0.3. Determine the acceleration of the block down the plane. First of all, let's just draw a schematic diagram of what they are trying to tell us, and we will have something like this. Now, if I take my meter rule this way, right, and I should be able to draw a line this way. This baseline is talking about my horizontal ground, right? So this is my horizontal ground. So an inclined plane is this, right? Now it says it is, look at the question at the top right corner. The plane is inclined at 25 degrees to the horizontal. So this is horizontal, and the plane is inclined at what? 25 degrees, right? Now this is the block on the plane. This is the block on the plane. That is the block on the plane. Right? Now look at the question again. It says the coefficient of friction between the block and the plane is 0.3. We know very well that the coefficient of friction given us, the mu, is what? 0.3. And the angle of friction here is given as what? Let's say alpha, and that's giving us what? 25 degrees, right? Now if you look at the question, it says between the block and the plane is 0.3. We've written that. Determine the acceleration of the block. So we're looking for acceleration of the block, right? And we should take gravity as what? 9.81 meter per second square, right? So these are the data given in the question here. So we are told to, one key word you need to understand is a what? We said the object is what? The determine acceleration of the block down the inclined plane, right? So that means the force is going downward, right? We're moving downward. That is the acceleration of the block. So what you do is this. What you do is this. Since it is going down the inclined plane, that is the key word, right? So you say recall the summation, right, of f of x, which is the same thing as saying the force, and that will give me w, right, w sine, or you can easily say w sine. Let me use sine here. W sine alpha minus mu w cos alpha. So when you see object down an inclined plane, you put a negative, right? So I can take any of these two. So since we're looking for acceleration here and we're not giving weight, now we say that recall the force P, which is something as saying the summation of what? F of x is equals to what? Mass times acceleration, right? So I'll put my mass times acceleration to represent these guys equals to, we know that the W also is equals to what? Mass times what? Gravity, right? So we say this will be mg sine alpha minus mu mg cos alpha. Are we together? Now from here, what is common here? M and G is common to both sides. So if I bring M here times A is equals to mg into bracket sine alpha minus mu cos alpha. I just factorized. So since I have m here and I have m here, m will equate m, right? And we'll be left with what? A, right? So if I put my formula, G is what? 9.81 sine alpha is what? 25 minus mu is 0.3 cos 25. Now if I do that, acceleration A here will give me 9.81 into bracket sine 25 is going to give us, let's say that sine 25 will give us, we have on this, we have sine 25 is what? That is 0.4226. 0.4226 minus cos 25. Cos 25 is 0.906 times 0.3, and that will give us 0.2719. right? Now if I subtract these two, if I should write this now, I'll say that acceleration here will be giving us 9.81 into bracket 0.4266 minus 0.2719, and that will give us 0.151 or 0.1507, right? So if you multiply it times 9.81, that will give me acceleration is equals to what? 1.48 meter per second square. So that is the answer to that question. So here, object down an inclined plane. I'll write it here. Recall, object down an inclined plane. Don't forget that. Inclined plane. We have this formula here. So that's our first question. Now let's see another question again. Example 2. If you look at your top screen, the question says that a mass of 40 kilograms. So let's write our data down. That is what is important. So the data given in this question is, we have the mass of the object is equal to what? 40 kilogram, right? Then look at the question again. It's pushed up an inclined plane at constant velocity by force parallel to the plane, right? And the force is 0.25 kilonewton. So the P, which is equal to what? 0.25 kilonewton, and that's saying 250 newton, right? Question says, if the angle of inclination of the plane to the horizontal is 30 degrees, so the alpha is given as what? 30 degrees, right? And G, which is the gravity, G is given as what? 9.81 meter per second square, right? So determine the angle of friction, right? Should look forward our angle of friction, and that is given as what? The angle of friction can be given as theta. Let's use theta here. So I'll call it angle of friction. Angle of friction. Right, that's what we're looking for. Now, if you look at the question again, it says determine the angle of friction and hence the coefficient of what? Of friction between the mass and the plane. And we're looking for what? This. We're looking for this. That is the coefficient of what? Friction. Right? Now, let's first of all apply this and see what happens. So you can draw if you want to. It gives you an edge. So if I should do the same thing I did the other time, I place my rule. This is my horizontal plane. Right? I can decide it to face here if I want to. Nothing. Now the angle is what giving us alpha, and that is what 30 degree, right? And this we have here this. So from here, now the mass of this, our mass M, is given as what? 40 kilogram, right? Now it says the key word here is pushed up an inclined plane. This is down and is going up, right? So the force here P is dragging this block up an inclined plane. I'll say P is what? 250 Newton. Is that again? So what you simply do is that you write recall in the bracket object up and inclined plane, right, will be the summation of f of x is equals to p is equals to w sine alpha plus, now because it's up it's plus. If earlier question it was down, always negative. So we have mu this cos alpha, right? So if you move forward, we've given our force to be 200 and what? 250. So I have 250 equals to the W here is given as what? Mass times gravity sine alpha plus mu mass times gravity cos alpha, right? So this would mean 250. What is common to both sides? Mass times gravity is common. So in bracket I have sine alpha plus mu cos alpha, right? So from here we're having 250 is equals to, the mass is 40 kilograms, so 40 multiplied by 9.81 into bracket sine 30 plus mu is given as is unknown, cos alpha that will be cos 30. So from here we'll move forward. 250 is equals to 40 times 9.81. Let's see that. 40 times 9.81, that will give me 392.4. So we have 392.4 sine 30 will give me 0.5 plus cos 30 will give me 0.866 mu, 0.866 mu, right? So if I open, I can do it in different way here. Either I divide both sides by 3.942 or I expand, right? So let me expand. So this would be 250 is equals to 3.942, 3.92.4, 392.4 multiplied by 0.5. That will give me 196.2. I multiply this with this, plus I multiply this with this. We have 392.4 times 0.866, and that will give me 339.82 mu. So if I collect like terms here, this will come to this side. So it will be 250 minus 196.2 is equals to 339.82 mu. So if I divide both sides by 339.82, this will be, first of all, 250 minus 196.2, 250 minus 196.2, and that will give me 53. That will give me 53.8 equals to 339.82 mu. So if I divide both sides by 339.82, 339.82, this will equate this. So we will now say that mu here will give us what? Divided by 339.82. So that will give me 0.158. 0.158, right? 0.1583 or 0.158. Let me just put it this way. So there's no unit for our question of friction. Now the next question, look at your screen. We're now told to look for what? The angle of what? Friction, right? We're looking for, from our parameters, we've gotten this. The next one is this angle of friction. So how to get angle of friction? We're going to put that, recall, for angle of friction, recall my tan phi is equals to what? Is equals to mu, right? But what is mu? Mu is 0.1583. So we say the tan phi is equals to what? 0.1583, right? So the phi, which is the angle of friction, so I'll change this guy to be something like this. So that will give me tan inverse 0.1583. So this angle of friction will now give us shift tan inverse. So we're having 8.996. So we have 8.996 degrees. So that's our answer. That's how you calculate for the angle of friction. So you should not forget this relation here. It is very, very important, right? So if you found this video helpful, please don't forget to click on the subscribe button and also click on the like button also. Thanks for watching.